Quantum computers is bigger than that. Quantum computers is a hardware question. Quantum computer, you can fact check things. And then you can say, this is 90% correct, this is totally wrong.
But scientists using revolutionary quantum AI have just done the impossible. They are digitally reconstructing thousands of texts from the legendary Library of Alexandria. Could these reconstructed texts change everything we know about human history? Greatest wonder of the ancient world. Alexandria wasn't just any ancient city. Founded by Alexander the Great himself around 331 BCE, it quickly became the intellectual capital of the ancient world. But what made Alexandria truly special was its legendary library, perhaps the greatest collection of knowledge ever assembled in human history. For centuries, the destruction of this library has symbolized one of humanity's greatest cultural tragedies. Thousands of scrolls containing irreplaceable knowledge went up in flames or slowly crumbled to dust. The voices of countless ancient authors fell silent, leaving us with mere fragments and tantalizing references. But what if we could bring back those lost voices? What if modern technology could resurrect the knowledge that vanished 2 millennia ago? That's exactly what scientists at the Quantum Historical Reconstruction Project claim to have achieved in 2025. Using cutting-edge quantum computing trained on ancient linguistic patterns and surviving text fragments, they've begun reconstructing works long thought lost forever. We're not talking about recovering a few lost paragraphs here. These researchers claim they're bringing back complete works by Sappho, the brilliant poet whose surviving genuine verses amount to just 650 lines. They say they're recovering Aristotle's legendary second book of Poetics focused on comedy, a work scholars have hunted for centuries. This breakthrough doesn't just recover words on a page, it fundamentally changes our relationship with the past and our understanding of what can truly be lost. How quantum computing made it possible. The breakthrough happened when scientists combined a quantum classical hybrid AI system with thousands of ancient papyri fragments. They didn't discover new physical artifacts. Instead, they digitized existing fragments from places like Herculaneum, Oxyrhynchus, and previously untranslated Middle Eastern archives. What happened next amazed the academic world. The AI didn't just organize these fragments, it began generating stylistically accurate text that experts believe belongs to specific ancient authors. The system produced passages that scholars attribute to lost works by Sappho, Aristotle, and even early Egyptian texts on astronomy that were thought destroyed when the library declined. One reconstructed excerpt from what appears to be an ancient astronomical text speaks about the sky communicating through silence rather than thunder, revealing secrets of what they called the divine ether. This passage combines poetic language with astronomical insights in a way that impressed classical scholars worldwide. The system wasn't just making things up. It modeled what researchers call linguistic probability clouds based on each author's unique style, analyzing sentence patterns, rhythm, vocabulary choices, and philosophical frameworks. By studying the surviving fragments of authors like Sappho and Aristotle, the quantum system identified patterns that worked like a linguistic fingerprint. These fingerprints allowed the AI to reconstruct works with amazing accuracy, revealing that ancient Greek thinkers had potentially figured out early versions of gravity, atomic theory, created by inserted coins. These weren't primitive prototypes, but sophisticated technologies that wouldn't become commonplace again until thousands of years later. The reconstructed texts suggest the library contained far more advanced knowledge than previously believed. Water pumps, pneumatic tubes, even early steam-powered devices. The Great Library itself was more than just a collection of books. It was the world's first comprehensive research institution. Scholars lived and worked there, conducting experiments, writing commentaries, and teaching students from across the Mediterranean. At its height, it reportedly housed between 400,000 and 700,000 scrolls, a staggering number for the ancient world. The library wasn't destroyed in a single catastrophic event, as popular myths suggest. Rather, it declined through a series of disasters and gradual neglect over several centuries. Julius Caesar's fire in 48 BCE damaged part of it. Later, religious conflicts and changing political priorities reduced support for this bastion of learning. By the time of the Arab conquest of Egypt in 641 CE, the Great Library had largely ceased to exist as a functioning institution. What we lost wasn't just a collection of books, it was an entire intellectual ecosystem. The conversations, debates, and cross-pollination of ideas that happened when diverse thinkers worked in close proximity disappeared. Works by hundreds of authors vanished completely, leaving us with tantalizing references and fragments that hint at vast bodies of lost knowledge. The technology behind the digital resurrection. The technology powering these reconstructions isn't just advanced, it's revolutionary. The quantum system that enables these textual resurrections uses what researchers call entangled linguistic vectors, a fancy way of saying the system can handle language patterns in an entirely new way. Unlike traditional AI that looks at words one after another, this quantum system tests billions of possible text reconstructions all at once, something regular computers simply can't do. This approach builds on ideas from pioneers in quantum computing. What makes quantum computing so powerful for this job is that ancient texts often contain gaps and unclear parts that create countless possible interpretations. Traditional computers would need centuries to explore all these possibilities. But quantum processors can check them all at the same time. The system uses a team approach between quantum and classical computing. Regular AI handles the basic preparation, organizing fragments, identifying languages, and setting up context. Then the quantum processors explore massive numbers of language patterns, checking countless potential reconstructions simultaneously. Classical systems then clean up and refine these outputs, creating a feedback loop that gets more accurate with each cycle. The most impressive part is the system's ability to handle connections between ideas that might appear far apart in a text, but are linked in meaning. This lets the AI rebuild complete arguments and stories from scattered fragments, keeping everything logically consistent even when only pieces survive. When researchers tested the system with known incomplete texts and kept portions hidden as a control test, the AI rebuilt the missing sections with 83% accuracy, a level of precision previously thought impossible. Even more impressively, when tested against recently discovered fragments that weren't in the training data, the reconstructions matched the actual discoveries in ways that convinced many classical scholars the system was onto something real. Ancient voices speak again. The recovered texts span an amazing range of ancient knowledge, from poetry and philosophy to astronomy and mathematics. Let's look at a few of the most significant reconstructions that have emerged from the quantum system. One of the most striking recoveries involves the lost works of Sappho, the renowned poet from the island of Lesbos. Despite her fame in the ancient world, only about 650 lines of her poetry survive today. The quantum AI has reconstructed what appears to be complete poems that match her distinctive meter and vocabulary. These reconstructions reveal a voice both deeply personal and universally relatable, exploring themes of love, desire, memory, and the natural world with a sophistication that feels surprisingly modern. Even more historically significant are the reconstructions attributed to Aristotle's lost works. While we have a lot of Aristotle's writing, scholars estimate it's only about a third of what he actually wrote. The AI has reconstructed portions of his lost second book of Poetics focused on comedy, a work philosophers have sought for centuries. The reconstructed text suggests Aristotle viewed comedy as more than just entertainment. He saw it as a way of exploring human flaws and social contradictions, a kind of ethical training through laughter. Another fascinating reconstruction comes from a text attributed to the philosopher Anaximander. The passage speaks of the boundless moving, not with the sun or moon, but with what they called the breath of the cosmos, with all things returning to it in necessity, as injustice in time must be paid. Researchers suggest this indicates a sophisticated understanding of cosmic forces we typically connect with much later scientific developments. One of the most thought-provoking reconstructions comes from a lost work attributed to Aristotle that speaks of movement without motion as not a contradiction, but a principle of light, describing that which remains, still yet causes change, as the soul of the cosmos. This mysterious passage has sparked debates among classical philosophers and modern physicists alike. Is this an early conception of field theory, the idea that forces can act across space without physical contact? Or is it simply poetic language typical of ancient philosophical writing? Perhaps most fascinating is what these reconstructed texts reveal: verification and reality checks. It's important to understand the boundaries of what has actually been achieved. No physical scrolls were discovered. This is a digital reconstruction based on surviving textual fragments and linguistic patterns. The outputs from the quantum AI system are probability-based reconstructions, not certainties. Each fragment comes with a confidence score indicating how likely it reflects the original text. The director of the Digital Archaeology Institute emphasizes they're not claiming to have magically found lost scrolls. What they have are sophisticated, evidence-based reconstructions that represent their best understanding of what these texts might have contained. The system sometimes produces what researchers call hallucinations, plausible sounding but entirely made-up content that doesn't match historical reality. The team has implemented strict verification protocols to filter these out, applying multiple layers of authentication before accepting a reconstruction as valid. How do researchers verify these reconstructions? First, they test the system against known texts with artificially removed sections. If the AI can accurately rebuild the missing portions, it demonstrates the approach works. Second, they cross-reference reconstructions against historical facts and archaeological evidence. Third, they examine linguistic fingerprints, the sentence structure, word choice, metaphor usage, and philosophical frameworks to ensure they align with known works by these authors. Classical historians find it particularly convincing when these fragments connect to historical context we already know. They reference events, people, and ideas that make sense for the time period, sometimes in ways that reveal new connections between known historical facts. The most compelling validation comes when reconstructed passages align with partial fragments discovered through traditional archaeology, fragments too small to be meaningful on their own, but that suddenly makes sense when placed within the AI's larger reconstruction. In several cases, the quantum system reconstructed texts that were later confirmed by new papyrus discoveries, providing strong evidence for the method's validity. Nevertheless, significant limitations remain. The system works best with authors whose writing style is already well documented through surviving texts. It struggles with authors known only through brief fragments or secondary references. The confidence scores reflect these limitations, allowing scholars to distinguish between highly probable reconstructions and more speculative ones, from fiction to future reality. As this technology matures, the implications grow more profound. Could this approach eventually reconstruct complete philosophical works? What happens when AI completes Plato's unfinished dialogues or recovers the lost comedies of Aristophanes? The reconstructed works could fundamentally change our understanding of ancient thought. For instance, preliminary analysis suggests Aristotle's lost book on comedy contains insights into human psychology that anticipate modern theories by millennia. This raises fascinating questions about intellectual history. How many modern discoveries were actually rediscoveries of ancient knowledge lost when the library declined? Educational applications are already being developed. These reconstructed texts could revolutionize how we teach classical studies, providing students with a much richer corpus of ancient literature to explore. Educational technologists are developing immersive virtual environments where students can visit the recreated Library of Alexandria and interact with AI reconstructions of ancient scholars. The technology has applications far beyond Alexandria. Researchers are planning to expand their work dramatically, applying similar methods to other lost textual traditions around the world. Long-term goals include cross-training the quantum AI on oral traditions, indigenous knowledge systems, and encoded artifacts from civilizations worldwide. The aim is to create a comprehensive digital resurrection of human intellectual history. An anthropologist working with the project explains they're developing protocols to incorporate non-textual knowledge systems. Many cultures preserved their wisdom through oral traditions, symbolic art, or ritual practices rather than written texts. These are equally valuable forms of knowledge that they hope to recover using adapted versions of the quantum reconstruction approach. The implications extend beyond historical curiosity. This technology could serve as a cultural black box recorder for future generations, preserving not just what we explicitly record, but the underlying patterns of thought that characterize our time. Some futurists speculate that quantum AI might eventually bridge the gap between different historical periods, allowing us to trace how concepts evolved across millennia. The project's director believes what they're building is essentially a time machine for ideas. We can't physically visit the past, but we can reconstruct the mental landscapes of earlier eras with increasing accuracy. This approach could help recover not just individual texts, but entire intellectual ecosystems, the conversations, debates, and cross-pollination of ideas that made institutions like the Library of Alexandria so pivotal to human development. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.